In this video, we're going to take a look at exponential and logarithmic equations, specifically those involving log base e, the natural log. Before we get started, we need to review our critical facts. Here's the fact we've been using so far in class, that 10 raised to log base 10 of x equals x. 10 to the x power and log base 10 of x are inverse functions, and they allow x to escape. But we can use that with natural log as well. Keep in mind that natural log is just log base e, so e raised to log natural log x equals x. Works in the other direction as well. A natural log of e to the x equals x. And we're going to use this to help solve some equations here. So in our first example, we're going to see a variable trapped up in the exponent. We'll see e floating around as well. What we like to do first is do some algebraic housekeeping. We're going to move the 7 to the other side by subtracting it. Divide both sides by 15. We have e to the 1 minus 3x power equals 1/5. At this point, we need to recognize that taking the natural log of both sides will allow natural log and e to the x, which are inverse ideas, to undo each other, and we get 1 minus 3x equals natural log of 1/5. From here, we're pretty home free. We're going to subtract 1 from both sides. And then we could divide by -3. That gets a little messy. Instead, I'm just going to multiply both sides by -1/3, and we have this expression. This is now something we can put into our calculators and find the value of x, which you'll find to be about 0.8698. Here's our second example. In our second example, we have a natural log of 2x minus 1 equals 3. Before we get started, let's think about the domain of x in this equation here. Keep in mind that 2x minus 1 here, when you take the natural log of something, whatever you're taking the natural log of must be greater than 0. So keep in mind the domain here, that 2x minus 1 must be greater than 0. Whatever answer we get must be greater than 1/2. We're going to tuck that fact away in our pocket as we solve this one. So the way that we're going to eliminate natural log here is to make that the exponent when we raise both sides e to that power. So if I do that here, e being the base of both sides, e to the natural log of x is just x. So we end up with 2x minus 1 equals e to the third power. Well, from here I can pretty much see my way clear. I'm just solving for x, so I'm going to add 1 to both sides, divide both sides by 2. We see that x equals e to the third plus 1 over 2. One thing to keep in mind that's oftentimes forgettable to beginning students is that e is a number. It's about 2.72. We can put it into our calculator, and we can find out that x is about 10.543 here, which is bigger than the 1/2 that we were looking for, and definitely in the domain of this problem.